Good morning, myself Deepa, working as an assistant professor in Department of Computer Science. Today my lecture topic is conversion of NFA into DFA. First we see what is FA. Here FA stands for finite automata it is a mathematical model. This model accepts only the finite input. So we can say this model is also called as computational model. Now we see the formal definition. The formal definition of FA machine is M equal to Q comma epsilon comma del comma Q naught comma F naught. Here Q stands for set of states, epsilon stands for set of inputs, del is a transition function, Q naught is the initial state and F naught is final state. This FA machine is classified into two types. One is NFA and another one is DFA. Here NFA stands for non-deterministic finite automata, whereas DFA stands for deterministic finite automata. The main difference between NFA and DFA is, in NFA for one input it will go for n number of outputs. In DFA one input it will go for only one input. For example, here we take two states, that is Q0 and Q1. We will take one input A. For Q0, if we give A, it will go for Q0 as well as Q1. For example, del of Q0 comma A, it will go for Q0 as well as Q1. But in DFA, A is the input. If I give this input as for the state Q0, it will go for only one state, that is Q1. So del of Q0 comma A, it will go for Q1. Here del of current state comma input is equal to 2 power Q. Why we are representing as a 2 power Q means, for one input, for one state, it will go for n number of state. That way, that only we are representing as a 2 power Q. Here del of current state comma input, it will go for only one state. For one input it will go for only one state. One more main difference is, in NFA there is epsilon transition. Transition is allowed. What do you mean by epsilon is, it is also one kind of input symbol. For example, Q0 and Q1. There is no input to move from Q0 to Q1. We can use this epsilon symbol as an input, move from Q0 to Q1. But in DFA, no epsilon transition is allowed. Now we see the conversion can be done in three ways. The first conversion is we can able to convert NFA to DFA. We can convert NFA with epsilon to DFA. Another one is NFA with epsilon to NFA. So among these three conversion, today I am going to discuss only about the first conversion, that is NFA to DFA. This NFA to DFA conversion need two steps. The first step is NFA states are converted into DFA states. So Q0, Q1 is converted as Q0, Q1. The NFA states are represented using a flower bracket. Once after converting into a DFA state, it should be represented in a square brackets. The second important step is let me take one example and see this step. For example, del of Q0, 0. If we go for this transition function, the output will be Q0 and Q3. Q0, Q3. We have to analyze whether the step is already exist in a transition table. But the old state is Q0. But our state is Q0 and Q3. So this one is considered as a new state. If any new state is occur when we converting the NFA state into DFA state, at the time for this new state you have to apply the input. So our input is 0, 1. So for both input you have to apply for the new states. If it is old state, no need, we can stop the old state. These are the steps we have to keep in our mind while we converting the NFA into DFA. Now let me take one problem and convert that one into a DFA. So this is a NFA problem. We convert this one into a DFA. So what's the main definition of FA machine is M equal to Q, epsilon, del, Q0, F0. So here the Q stands for set of states. In our problem we have two states, that is Q0, Q1. So epsilon stands for set of input. In our problem we have two inputs, that is 0, 1. Del is the transition function we have to apply while we converting the NFA states into DFA. Q0 stands as the initial state. In our problem we have Q0 as a initial state. Then F0 stands for final state. In our problem Q1 is considered as a final state. So now we have written the formal definition of this NFA diagram. Next we need to construct the transition table, that is NFA transition table. Still now we not yet converted the problem into DFA. So transition table represents both state as well as input. So in this problem we have two states, that is Q0 and Q1. In this Q naught is considered to be an initial state. That's why I represented using an arrow mark. Here Q1 is considered to be a final state. So I am representing in a double circle. So input is 0 and 1. So 0 and 1. We have to fill this table. For Q naught, if we give 0, it goes for Q naught. It goes for Q naught as well as Q1. The next, if you give 1 for the Q naught state, it will go for Q1. So for the state Q1, if you give 0, Q1, if you give 0, this is a state Q1, if you give 0, there is no input, so we are representing this state as a pi. For Q1, if you give 1, it will go for Q1 as well as Q naught. So I am writing as Q naught, comma Q1. So still now I not yet converted this problem into DFA, only I transmitted this transition diagram as a transition table. Now I am going to apply a DFA transition function. So while converting a DFA transition function, we have to keep two things in our mind. One is when we find a new state, we have to apply the input. If it is a old state, we have to leave. That is one step. Another one important step is after converting the states into a DFA, it should be represented in a square bracket. So while converting, you keep this step in your mind. So first, we have to apply the transition state for available state. Here the available state is Q naught and Q1. For this state, we need to apply the input 0 and 1. For del of Q naught comma 0, if we give Q naught comma 0, it automatically goes for Q naught comma Q1. So now the states are in NFA. We need to convert this one into DFA. So now del is representing the NFA state. For DFA, it represented as del dash of Q naught comma 0 is equal to Q naught comma Q1. Now I am representing the states in a DFA. After getting the states, we need to check the state is available in our transition table. So available state is Q naught and Q1. Here we get the state Q naught Q1. So it is considered to be it is different because our available state is Q naught is separate state and Q1 is a separate state. So here we combinedly we have Q naught Q1. So we are taking this state as a new state. Next we need to apply, now 0 is completed. Now we need to apply 1 for Q naught. So del of Q naught comma 1, it will go for Q naught comma 1, it will go for Q1. So I need to convert this one as a DFA. So del dash of Q naught comma 1 is equal to Q1. Now I need to check whether the state is available in the table. So Q1 is available state. So we need not to consider this state as a new state because it is already available in a table. So we leave. Next one is del of Q1 comma 0. We need to apply now Q1 comma 0. It is a pi state. So we need not to consider this state because there is no state. We can leave. Del dash of Q1 comma 0 is pi. It is also, we need not to consider this one. Next one is del of, now you apply Q1 comma 1. Q1 comma 1. It goes for Q1 comma 1. It will go for Q naught and Q1. So Q naught comma Q1. Convert it to a DFA. So I am writing in a del dash. Del dash of Q1 comma 1 is, in square bracket I am representing the states Q naught and Q1. So it is a new state. So because the available state is Q naught and Q1, so here we get Q naught and Q1. But this status already exists in a first step. So we need not to consider for second time. We can leave it. So after putting a transition function for existing state, that is here existing state is Q naught. For Q naught I applied 0, Q naught I applied 1, then Q1 I applied 0, Q1 I applied 1. After completing this basic step, I need to check whether any new status occur. Yes, here one new status occur, that is Q0 and Q0 comma Q1. For this new state, again I need to apply inputs. So del of Q0 comma Q1 comma, first I am applying the input 0 here. So I get del of Q0 comma 0 union del of Q1 comma 0. So I applied Q0 comma 0, then Q1 comma 0. So del of Q0 comma 0 is Q0 comma 0 is Q0 Q1. So Q0 comma 0 is, I get the answer as Q0 comma Q1 union del of Q1 comma 0. The next state is Q1 comma 0. It is pi. So the state is Q0 comma Q1. So it is in a NFA. I need to write in a DFA. So I am writing in a del dash function. So del dash of Q0 comma 1 comma 0 is represented as Q0 comma Q1. So here also we need to represent in a square bracket. Del dash of Q0 comma Q1 comma 0 is, we will get Q0 and Q1. We have to check whether the status already exists. Yeah, it is already exists in a first step. So we need not to consider again. So for this new state I applied 0. Now I am going to apply 1 for that new state. So del of Q0 comma Q1, I am applying 1. So now I get del of Q0 comma 1 union del of Q1 comma 1. So Q0 comma, you see the transition table, Q0 comma 0, again I get Q0 comma 1 union Q1 comma 1. If I give Q1 comma 1, it goes for Q0 comma 1, Q0 comma 1, it goes for Q1. Q0 comma 1, it goes for Q1 union Q1 comma 1, it goes for Q0 comma Q1. So after taking a union on this two transition function, I get a result as Q0 Q1. It is in NFA. Now I need to convert into a DFA. So I am writing as a transition function as del dash. Del dash of Q0 comma Q1 comma 1. It will go for Q0 comma Q1. So I need to check whether the status already exists. Yes, it is also already existed. So it is considered to be not a new state now. So I have completed the DFA transition function. Now I need to draw the DFA transition diagram and table. First I will construct the DFA transition table. So we all know the procedure to draw the DFA transition table. It consists of states as well as inputs. Here, after converting into a DFA, we received a new state. So already initial status Q0, it is considered to be an initial state, and then another status Q1, it is considered to be a final state. And one more new state we have founded. After converted into a DFA, we received a new state, that is Q0 and Q1, that is also considered while we drawing a DFA transition table, that is Q0 comma Q1. This all are DFA state, that's why I am representing in a square brackets. So now we need to find this is also a final state or not. So after finding a new state, the state has a same state as a final state, then we need to consider this new state is also to be a final state. Here the Q1 is considered to be a final state. We have founded the new state, that is Q0 comma Q1. Here also we have the Q1 state. So this state is also to be a final state. So I am putting a double circle. Now the inputs are 0 and 1. Now you see, if you give Q0 comma 0, it will go for Q0 comma Q1. For Q0, if you give 1, it will go for Q1. So now I am constructing a DFA transition table. So state should be represented only with these square brackets. For Q1, if you give 0, there is no state. So it is represented as a pi. For Q1, if you give 1, it will go for Q0 comma Q1. For this new state, if you give 0, Q0 comma Q1, if you give 0, it will go for Q0 comma Q1. For 1, Q0 comma 1, if you give 1, automatically it goes for Q0 comma Q1. So this is a DFA transition table. For this table, we need to construct the transition diagram. So how many states we have in DFA transition table? We have a 3 states. So Q0 is a state, then we have a Q1, then we have a Q0 Q1 as a states. So totally we have a 3 states, Q0 comma Q1. So here the Q0 is considered to be an initial state and Q1 is considered to be a final state. That's why I am representing in a double circle. Here this Q0 comma Q1, it is also considered to be a final state because we have the state Q1 here. That's why we are considering this state is also a final state. Now you apply for Q0, if you give 0, it will go for Q0 Q1. So 0, it will come here. Then for Q0, if you apply 1, it will go for Q1. So if I give 1, it will come here. Then Q1, if I give 0, there is no state transition. Q1, if I give 1, automatically it comes to Q0 Q1. Then last state Q0 Q1, if I give 0, it will go for Q0 and Q1 state. For 1, it is also going for the same state. That's why I am representing in a 0 bar 1. So now we have converted entire NFA problem into a DFA transition diagram. So what's the purpose to convert this means? In NFA, one state it will go for n number of inputs. So it takes long computational time. To reduce that computational time, we are converting the NFA diagram into a DFA transition. Here you see, if for one state it will go for only one input. For Q0, if you give 1, it will go only for Q1. Q0, if you give 0, it go only for Q0 and Q1. So for one input, it will go for only one state. Because of that, the computational time is very less in our DFA diagram. That's all. Thank you.